When you think about security in programming, you probably think about locks and keys and walls, right? But what if I told you that Python's entire system is built on something totally different? It's built on trust. Today, we're going to decode the secret handshake that governs Python's code. It's less about rules and more about a code of conduct. So let me ask you this. Have you ever been digging through a code base and you just get this vibe, this feeling that some parts of it are kind of off limits? Python is really good at creating that feeling, but not with fortress walls. It does it with these subtle hints. Let's dive in and figure out what they mean, and more importantly, why they matter. Okay, to really get this, let's picture our code as a building. By default, whenever you write a class in Python, you're basically starting everyone off in the public lobby. The doors are wide open, everything is accessible, and there are absolutely no restricted areas. So, what this open door policy really means is that right out of the box, every single thing in a class is public. You can read it, you can change it, you can mess with it from anywhere else in your program. And while that's super simple and great for quick scripts, you can probably imagine that in a giant, complex project, this could lead to, well, chaos. It can cause these really hard to track bugs. All right, let's look at some actual code. Here we have a simple student class. Now look closely at name and age. Do you notice anything missing? There are no special symbols, no weird prefixes. That's your first huge clue. It means they're completely 100% public. Okay, so let's run this and see what happens. We create a new student, Alice. We can print her name, no problem at all. But, and this is the important part, we can also just reach in and change her age. Just like that, from 20 to 21, no questions asked. This total access is our starting point. Now, the public lobby is fine and all, but some parts of our building need to be a little more restricted, right? So imagine you're walking down a hallway and you see a door with a sign on it that says staff only. The door isn't locked, but that sign is a pretty clear warning. That is exactly what a single underscore does in Python. And this is super important to get. That single underscore, it's just a convention. It's not a rule that Python is going to enforce. You should think of it like a gentleman's agreement between you and any other developer who looks at your code. It's a signal that says, hey, this is for internal use. If you change it from the outside, you might break something. For example, in this employee class, the name is public, no big deal. But notice under salary, that's our staff-only area. A developer would mark it like this, because maybe other methods inside this class, like a tax calculation or a bonus payout function, depend on that salary being a very specific, validated number. If you just change it carelessly from the outside, you could break the whole thing. So what happens if we decide to ignore that sign? Well, let's try it. We run this code, we directly access emp.salary. And this right here perfectly illustrates a core piece of Python's philosophy. Trust the developer. Python gives you the power, but it also trusts you to follow the signs and use that power responsibly. It's all about keeping the code predictable and stable. Okay, a please don't touch sign is one thing, but what about the really sensitive data? The kind of stuff where an accidental change would be an absolute disaster. Well, now we're at the bank vault. It's marked with a double underscore, and that's a signal that it's meant to be private. This is where Python finally takes an active role. When it sees those two underscores, it performs something called name mangling. It's a fancy term, but all it really means is that Python literally renames the attribute behind the scenes to make it way harder to access by accident. So in our bank account class, underscore balance is private. I mean, you definitely don't want some random part of your program to be able to set a bank balance to a negative number, right? So instead of allowing direct access, the class provides a safe, public method, get underscore balance. This is the intended front door you're supposed to use. So what happens if we try to bypass that intended method? What if we try to pick the lock on this private vault and grab the balance directly? Let's watch our code fail. Okay, here's our attempt. We create an account for David, and then we try to print account.balance straight up. We're about to run this. Based on what we now know about name mangling, what do you think is going to happen? And there it is, a crash. We get an attribute error. The program just stops. Why? Because as far as the outside world is concerned, there is no attribute called underscore balance. The name mangling has successfully stopped us from making an accidental direct access. So how do we fix this error? Well, there's the right way, using the methods the class gives us, but Python also has that secret handshake for those really rare cases, like debugging when you absolutely must get inside. On the left, you can see the direct access attempt that fails. It crashes our program. On the right, you see the correct approach, using the public get underscore balance method. This is the safe and intended path. It gives us the data we want without any of the risk. And here is the secret. Name mangling isn't just random. It follows a very clear pattern. Python doesn't delete the attribute. It just renames it to a single underscore, the class name, and then the original attribute name. So underscore underscore balance becomes underscore bank account underscore underscore balance. This shows that even private attributes aren't completely inaccessible in Python. If you know the mangled name, you can get in. But, and I can't stress this enough, accessing them this way is a major red flag. This is a tool for debugging or testing, not something you should ever do in your regular application code. So after all that, what is the big takeaway here? How should you approach all this in your own Python projects? Well, it all really boils down to communication. Public is open access. Protected, with one underscore, is a polite request to stay out. And private, with two underscores, is Python actively helping you avoid accidents. But remember the core idea. Python's system is about communication and trust, not about creating these impenetrable fortresses. I really like this way of thinking about it. The underscores are just like traffic signs. They're there to guide you, to keep your code organized, predictable, and safe. Python trusts you to follow them, but it's not going to physically stop your car if you decide to blow through a red light. And that leaves us with a final thought. This whole philosophy of we're all consenting adults here, this deep trust in the developer, is that a brilliant feature that promotes flexibility and responsibility? Or is it a bug just waiting to cause problems in large, complex systems? It's one of the defining traits of the language. Thanks for joining me.